In this video, I will add a robot arm to the pie car. I use the EasyBot arm design, which is available in Thingiverse for 3D printing. You can find the link in the description. If you don't have a 3D printer, you can buy a robot arm kit like this one. I haven't tried it, so I'm not sure about the size. You may need to figure out a good way to mount it to the pie car. This is the robot arm base I printed. I will use it to replace the camera. I already removed the screw, so you can take it off. So luckily, the two holes here fit right into the two standoffs. The only thing is that the screw part is not high enough, so it doesn't come out, so you cannot put nuts on. So I will also remove this plate. By the way, this box is also 3D printed to prevent the pie car from being covered by dust and dog hairs. Now they fit perfectly. So the only problem is that this point is not fixed yet, so the base still wiggles. To fix it, I designed and printed this. It's a pretty easy design, just a Z shape with holes. I include that zip file in the GitHub. So we put it here, and then we can connect the base, the lower plate with the base. Now it won't wiggle anymore. I also designed this to mount the camera in front of the base. Here, so you can put the camera on. Notice the two bumps here? It's to make sure the camera is always mounted at the same position. So this camera will always look at the object that we are going to pick up. Later, I will mount another camera to the robot arm, so when moving the arm, I can also control the angle of the camera. Now we put the robot arm on the car. We put this part first. After put it on the car, we connect the servo to the PWM driver here. We have talked before that the PWM driver can support 16 servos. For the clamp servo, the wire is not long enough, so you need to extend it. Now let's connect them. I put it at the channel 6, 7, 8, 9. By the way, I did another modification to the finger. So the original design, this part is flat. So I changed it to be curved. So it's easier to grip the round thing like the head of a Lego figure. For the additional camera here, I use a Picamera module. You need to connect it with the Raspberry Pi using this kind of cable. So you need to take off the robot head and connect it with the Raspberry Pi directly. I also included a more detailed instruction in the description. First, locate the camera module port. Gently pull on the edges of the port's plastic clip. Then insert the camera module ribbon cable. Make sure the connectors at the bottom of the ribbon cable are facing the contacts in the port. After that, you can push the plastic clip back. You also need to go to Raspberry Pi Preference to enable the camera. Now let's go to the code part. First, let's enable the second camera stream. The second camera stream is Picamera module. We need different codes to capture frames. I added a class camera stream in stream.py. The start function starts a recording stream. The stream will keep recording in the background and write captured content to streams continuously. Since the content was written to the stream continuously, we need to know where the frame boundaries are to split them. Luckily, this is relatively easy as the JPEG format has a simple magic number FFD8. Once we see this magic number in buff, we know a new frame is starting. So we put existing content in the stream to current frame and clear the stream. This is the fastest way that Picamera can capture and process video. It can easily deal with 30 frames per second. The other function, capture continuous, can only reach around 19 frames per second. We implement the getFrame function to return the current frame, just as what video camera class's getFrame function does. So the gen function we used before can be reused to generate frame stream. It just requires the input parameter has a function called getFrame, so now we can pass camera stream to it. In urls.py, we add a new URL representing the stream for the second camera. In views.py, at the beginning, we create a camera stream instance, then start the recording stream. Note that the start function will keep running. We need to put it into a separate thread, otherwise it will block the other codes. With the recording running in the background, now this function can return the video stream. Next, we add code to control the robot arm. I added a file robotarm.py. We first specify the channel number for each servo. These are where we plug servos in the PWM driver. Then in the init function, we initialize the servos and current angles. The other codes are easy to understand. The pan forward and vertical function controls the 3 servos to pan, move forward and vertically. To position moves all 3 servos to a specific position. The open clamp and close clamp open and close the fingers. One thing worth talking about is that I use 2 moving modes. Let's take the pan function as an example. If smooth is false, it just writes the target angle directly into the servo. The servo will move to this angle as fast as it can. If smooth is true, it moves in the smooth mode, which breaks down the one move into many small moves, each at most 2 angles. You can see the difference between these 2 modes. When moving fast, it wiggles more. Then I define the pickup function to pick up the object in front of the car. I use the smooth mode, and I also broke the whole move down into multiple moves to further smooth the movement. Now we change the run.html to add elements. The new UI now looks like this. First, we add the second stream div to show the 2 video streams. I removed the original camera control buttons since we won't need them anymore. Also, the original buttons can only control the camera to a fixed angle. I reorganized the buttons and added slide bars to control the arm. Let's take the pan slide as an example. The code for the slide bar is like this. The minus and plus button are for fun controls. Each time they are clicked, they'll call the arm pan minus or arm pan plus function, which will add or reduce the slide value by 1. For the slide bar, each time the slide value changes, the onInput event will be triggered, which calls the arm pan value function with the new value. The arm pan value function gets the new value, then calls the roboarm function with the parameter pan and the value. The roboarm function constructs the HTTP request. The requester will include this arm equals part. For the pan case, if the current value of the slide bar is 90, then this part will be arm equals pan colon 90. In the run function of views.py, we also need some new code to deal with this request. This splits the action and parameters part of the pan request. In this example, the action will be pan and the parameter will be 90. Then it will call roboarm's pan function with the angle. The pickup button's HTML code is like this. When clicked, it calls roboarm with parameter pickup and 1. Here 1 is just a dummy angle, so in views.py all requests can be processed in the same way. Now we are ready to control the arm. We can control the car to move around and control the arm to point the camera in different directions. To pick up a Lego figure, I put it at the bottom edge of the camera, then click Pick Up.